Now let's discuss common table expressions, or CTEs. They're actually an alternative to using subqueries, derived tables, and temporary tables. They're similar to derived tables, but they offer the advantage of being self-referencing. And they can actually be referenced numerous times within the same query. Because of this, recursion is possible. CTEs reduce the need for cursors, temporary tables, and complex logic to derive recursive results. In this section, we'll introduce the benefits, syntax, and typical uses for both recursive and non-recursive common table expressions. The most common uses for CTEs are as follows. Maybe you'll use them in place of a view. Views are actually persistent objects, and that may be overkill. CTEs enable grouping by a column derived from a scalar subquery, or a function that's not deterministic or has external access. You'll use them when there's a need to reference the resulting table numerous times within the same statement. For example, CTEs make the retrieval of hierarchical data more straightforward. Let's take a look at the syntax for creating a CTE. CTEs are named expressions along with queries that define their structure. Once defined, you can reference it much like a table or view, and you'll use it with any T-SQL select, insert, update, delete, or create view statement. The syntax is with expression name, with the name of your CTE. You can list the columns that you want to define, or you'll define the structure by using a select statement. Here's a note. The list of column names is only optional if the CTE query definition explicitly names the columns. So let's go take a look at an example of a CTE. In this example, we're taking a look at a common table expression. And here you can see the syntax for creating that CTE. Highlight that all for us so it's a little easier to see. We name the CTE, in this case pay rate, and we're indicating the columns that we want to include, and we're indicating what its definition is. How are we going to get that business entity ID and max date? Well, we're doing that by executing this select statement. So for every business entity ID or ID of the employee, go get the last rate change date from the employee pay history and make that the max date value for that ID. So here's a way that we're going through. Remember, we took a look at using a temp table and using a subquery to calculate the latest pay rate for someone. And in this case, what we're going to do is say, look, let's go get the last time their pay rate changed for every employee. We will store that in a CTE. Notice there's no create table, there's none of that, there's no temporary table going on. This will now be available to us, and once it is defined, we'll then use it in a select statement that follows. And you'll see here that we're using that CTE to handle the joins. So we will take the business entity ID defined in that CTE, one row for every employee, and we will use that to tie back to our employee table. And then we'll also use the ID and date for each employee, the max date, the last time their pay rate changed. We'll tie that back to our employee pay history, and all of a sudden we have the joins taken care of, and we now have the same information we produced in the last two examples. The example of the temp table and the example with the subquery, which is, hey, let's get their current hourly rate. Very simple to do, very straightforward, pretty powerful. and we're not having to deal with the temporary tables or complex subqueries. Pretty neat construct available to us, the common table expression. So now let's take a look at common table expressions and how they can be used in recursion. In mathematics and computing, recursion describes the process of executing a function that calls itself, and it calls itself a repeated number of times in order to produce the desired results. Examples of recursive processes are things like generating a Fibonacci series of numbers, reporting the structure of an organization, and listing all of the component parts of a product, where some of those components are themselves made up of one or more separate pieces. A really nice feature of the common table expression is that they can reference themselves. Because of that, they're ideal for handling recursive tasks. Recursive CTEs really simplify the code for calling those recursive queries. They remove the need for cursors, temporary tables, and the overhead of complex logic to generate that data set. There are two parts to a recursive task. The base case, which describes what to do when computing the result no longer requires another call to the function. And then there's the recursive step. That contains the details of the actions to take, including calling the function again when the process needs to make one or more additional recursive calls in order to reach that base case. CTEs are SQL Server constructs, so building a base case and recursive step in T-SQL requires the following. First, we have to define one or more CTE query expressions that we join together using union all, union, except, or intersect. None of those are going to refer to the CTE itself. That's referred to as the anchor members. Anchor members are really the base case. Then we're going to have one or more CTE query expressions that we join by union all that actually references the CTE name itself. This is the recursive step, or in T-SQL parlance, recursive members. The termination of the recursive query when a call to the CTE returns no rows is how the process ends. So here's some key terms. First of all, we have a base case. Those are the steps that we need to perform when no additional call to the function is required. We have a recursive step. This contains operations to perform when there's additional processing required, and often that includes calling the function itself. Now, when we want to do this as a CTE, we have the base case and recursive step really map out to what SQL calls anchor members and recursive members. Anchor members are one or more CTE query definitions that correspond to the base case. They're joined together, but they don't reference the CTE. There are one or more CTE query definitions that correspond to the base case. Each one of those CTE query definitions are joined using a union all, union, except, or intersect, but they don't reference the CTE directly. Recursive members, on the other hand, are definitions that are also joined together using union all, but they do reference the CTE query. That's how they call themselves recursively. So if we list these out as distinct steps, when you want to construct a recursive CTE, you'll do the following. Define the needed CTE queries and decide which ones are anchors and which ones are recursive members. Execute the anchor member queries to produce the base case. Execute the recursive member queries using the results from the prior invocation as inputs. And then you'll continue step 3 until all the recursive call produces is an empty result set. Returning a union all result set consisting of the result sets returned by the anchor and recursive members gives you your final result. Here's a warning though. Make sure that the recursive members actually produce results that eventually lead to an empty result set. If you don't do that, you'll end up in an infinite loop. The syntax for a recursive CTE is as follows. With CTE name, as, and then we have a CTE query definition. That's the anchor member. Then we're going to union all of that with another CTE query definition. That's the recursive member. And the reason it's recursive is that within that CTE query definition, it references the CTE name again. So let's head over to SSMS and take a look at how it's done. Okay, here we're going to take a look at a recursive CTE definition and how we might use it in a query. You'll see here that the objective is to produce a sales organization list, and we're going to build this list. It's going to contain a manager ID, the employee ID, and what level of the organization we're talking about. So remember, recursive CTEs consist of two parts, the anchor and the recursive member. The anchor member has to have some way of completing the process. So you'll see here our select statement is going to get the parent of the current employee, and that's going to be known as the manager. And it's going to return the level that the employee is associated with. And we'll know that we've reached that anchor member when the organization level is 0. We're at the top of the org chart at that point. Okay, so that's kind of our fallout condition. That's where we're going to go when we no longer have to traverse the organization tree. Once we've done that, we're going to union that with all of these recursive calls. And here is where we actually refer to the CTE itself. Notice back in the anchor member definition, there's no reference to the CTE. It's just a very simple standalone statement. I could execute that and I'd get some values. Down here in the recursive portion is where we're going to actually refer to the CTE itself, and we're going to pass it some information. So here we go. We're going to select, again, we're doing the same type of query. We're getting our parent, which is really the manager. We're getting the employee ID and the level, and we're getting that from our employee table, but we're going to join our employee table with our CTE. And we're going to pass in the parent of the current employee. And so what happens is we'll start going through and bubbling up until there's no more recursion to be done. The two sets can then be joined together, and we have one structure that holds all of the rows in the right order, containing managers, employees, and levels. Once that's done, we can now take advantage of that structure, use it as a table, join it to our query, and return some results. So you'll see here we're actually using our sales org list. That's the CTE, just so that it's easy to remember. We're joining that CTE against employee based on the employee ID. Then we're picking up some information from the person table and the employee department history table, the current department, so forth and so on, so that we can get some interesting information about these employees as it relates to their position in the organization. And what we're going to do here is look at the sales department, but you'll also notice in that where clause is or the level number coming back in that CTE is 0. The reason that's there is that the president or CEO, the highest person in the organization, isn't classified as being part of the sales department. So we needed to add that little portion of the where clause there so that we pick up that row. In any event, let's go ahead and execute this, and you'll notice that there should only be one result returned for the anchor member. Then there'll be one or more for each of the recursive members, and we've organized them in such a way in the select statement that they'll be in order. So the top level will be president or CEO, highest level in the organization, that'll represent the anchor member, and then everything that follows is a recursive or child of that row. So let's go ahead and take a look at what it produces. And you'll see here, if I can grab that result window and stretch it a little bit, you'll see here that, well, that Ken Sanchez is our CEO. He's at the top. And then we have a vice president of sales. Remember, we're only looking at the sales department. So that's level 1. And then we have some folks who are at level 2. So they report to the person at level 1. And then all of the level 3s report to somebody in the second level of the organization. And of course, here, just for completeness, we've put their manager name in so that you could follow the org chart, so to speak. So just a quick example of how we can take advantage of CTE's ability to deal with recursion and how that can help us traverse some complex data such as hierarchical data.